As production ramps up and more details slowly leak out, the Model 2 begins to look less like a single product and more like a stress test for the entire global auto industry. Every assumption automakers rely on is being challenged at once. How fast a car can be built, how few parts it can contain, how cheap an EV can be without feeling disposable, and how much automation is too much. What makes this moment especially tense is that Tesla isn't experimenting in a lab or producing a limited run. It's attempting to scale this approach immediately at volumes that could reshape supply chains worldwide. One of the least discussed aspects of this strategy is how software replaces hardware in the Model 2. Traditional automakers often rely on physical components to differentiate trims and features. More buttons, more modules, more wiring. Tesla has spent years consolidating functionality into software-controlled systems, allowing the same hardware to support multiple configurations. This reduces complexity on the production line and allows Tesla to update, tweak, or even unlock features after the car is built. From a manufacturing perspective, fewer variations mean fewer disruptions, fewer errors, and faster throughput. From a business perspective, it creates ongoing revenue opportunities long after the initial sale. This approach also helps explain how Tesla can strip the car down without completely stripping its appeal. Even a basic Tesla still feels technologically modern because so much of the experience is driven by software. Navigation, driver assistance, energy management, and even basic vehicle behavior are controlled digitally. The interior may be simpler, but the car doesn't feel outdated. That balance is difficult for legacy automakers to achieve because their architectures were never designed with this level of software centralization in mind. Another factor, quietly working in Tesla's favor, is vertical integration. Like most automakers that depend heavily on third-party suppliers for critical components, Tesla designs and manufactures a surprising amount of the car in-house. Motors, inverters, battery packs, software, and even seats are often produced internally. This reduces supplier margins baked into the final cost and gives Tesla tighter control over timelines. When you're aiming for a car every 4.5 seconds, even small delays from an external supplier can ripple through the system. Owning more of the process reduces that risk. However, vertical integration cuts both ways. When something goes wrong, there's no supplier to absorb the shock. Tesla carries the full burden of any manufacturing misstep. This makes quality control absolutely critical, especially with large castings. A defect discovered late in the process can be far more expensive than in a traditional assembly system. Tesla's response has been to push quality checks earlier and rely heavily on real-time sensor data and AI-driven inspection systems. Cameras, scanners, and software monitor each step, flagging anomalies instantly. In theory, this allows problems to be caught before they propagate. In practice, it adds another layer of technological dependency. The labor implications of this shift are impossible to ignore. Highly automated factories require fewer line workers, but more engineers, technicians, and software specialists. This changes the skill profile of manufacturing jobs and concentrates expertise in fewer hands. Supporters argue this leads to safer, higher-paying roles. Critics worry about job displacement and the loss of manufacturing employment in regions that depend on it. Tesla's factories don't eliminate humans entirely, but they dramatically reduce the number needed per vehicle produced. As other manufacturers watch closely, the Model 2 becomes a preview of what large-scale industrial automation might look like across multiple industries, not just automotive. Competitors are paying attention, even if they're not saying much. Publicly, silence in this case is strategic. Acknowledging Tesla's claims would mean admitting that existing production systems may be fundamentally less efficient. But behind closed doors, legacy automakers are reportedly accelerating their own casting programs, revisiting platform designs, and reevaluating how many parts a car really needs. These changes take time. Factories are multi-billion-dollar investments designed to operate for decades. Retrofitting them for gigacasting or extreme automation isn't just expensive, it's disruptive. That inertia gives Tesla a window of opportunity, but it won't last forever. There's also a geopolitical layer to all of this. Affordable EVs are increasingly seen as strategic assets. Countries want domestic manufacturing, local supply chains, and reduced dependence on imported energy. A $20,000 electric car built at scale in the United States directly challenges Chinese dominance in low-cost EVs. It also puts pressure on European manufacturers struggling with higher labor and energy costs. Governments may respond with incentives, tariffs, or new regulations, all of which could affect how and where the Model 2 is produced and sold. From the consumer's perspective, the appeal of the Model 2 goes beyond price. Speed of production implies speed of delivery. Long wait times have been a persistent frustration in the EV market. If Tesla can truly maintain this pace, it could drastically shorten the gap between ordering a car and driving it home. That kind of responsiveness changes buying behavior. It makes EVs feel less like a special purchase and more like a normal, accessible option. Still, concerns remain about durability and long-term reliability. A car built this quickly raises intuitive doubts. People associate time with care, even when that association isn't always justified. Tesla will need years of real-world data to prove that extreme automation doesn't lead to hidden weaknesses. Structural castings, for example, may behave differently in collisions or after years of stress compared to traditional multi-part assemblies. Tesla insists that fewer joints and welds actually improve structural integrity. But widespread acceptance will only come after extensive testing and real-world experience. The battery, too, will be under scrutiny. Smaller packs are cheaper and lighter, but they also have less margin for degradation. Tesla's confidence rests on improved chemistry, thermal management, and software controls that minimize wear. If those systems perform as promised, the Model 2 could redefine expectations for what an affordable EV can deliver. If they don't, early adopters will be the first to notice. What makes this moment so compelling is that success or failure won't be incremental. If Tesla pulls this off, the implications cascade. Lower prices expand the EV market dramatically. Higher volumes accelerate charging infrastructure build-out. Software-driven platforms become the norm rather than the exception. Manufacturing jobs evolve, supply chains shrink, and the pace of innovation increases. If it stumbles, the backlash could slow adoption and reinforce skepticism about over-automation. Elon Musk has framed the Model 2 not just as a car, but as a solution to mass transportation. That framing matters. At $20,000 to $30,000, an EV stops being a niche product and starts competing directly with the most popular gas-powered cars in the world. The question shifts from, should I buy an electric car? To why wouldn't I? That psychological shift is arguably more important than any single technical breakthrough. As more information emerges, it becomes clear that the Model 2 is less about a specific feature set and more about a philosophy. Build fewer things, but build them better. Replace complexity with intelligence. Let machines do what machines are best at, and let software smooth out the rest. It's a vision that appeals to engineers and terrifies traditionalists. The coming years will determine whether this vision becomes the new standard or a bold outlier. What's certain is that the Model 2 has already succeeded in one crucial way. It has forced the industry to confront uncomfortable questions. How much of what we do is truly necessary? How much is habit, and how much is fear of change? A car every 4.5 seconds is not just a manufacturing milestone. It's a challenge to competitors, to regulators, to workers, and to consumers. It dares them to imagine a different future for transportation. One where speed, scale, and affordability are no longer mutually exclusive. Whether that future arrives smoothly or with turbulence remains to be seen, but the direction is clear. The rules that govern car manufacturing for the last century are being rewritten in real time. The Model 2 is the pen Tesla is using to do it. A car rolling off the production line every 4.5 seconds sounds almost unreal. That's faster than it takes to pour water into a kettle, faster than most people can unlock their phone and check a notification. While you're reading this, another Tesla has already taken shape, and then another. This isn't a concept video or a flashy demo reel. According to Tesla, this is the real production pace of its newest vehicle. The Model 2, at roughly $20,000, It's positioned as the company's cheapest car ever, but the price tag isn't the most shocking part. What truly has the auto industry on edge is the speed, the scale, and the radical rethink of how a car is even built. For decades, automakers have accepted certain limits as unbreakable laws. Cars are complex machines with thousands of parts. Assembly lines move at carefully controlled speeds. Push them to fast and quality drops. Defects rise and costs spiral out of control. Even the most efficient manufacturers in the world, companies like Toyota that practically invented modern lean manufacturing, average around a minute per vehicle at their best plants. 45 seconds if everything goes perfectly. It's that benchmark. Has stood for years as the gold standard. Tesla's claim of a completed vehicle every 4.5 seconds doesn't just beat that record, obliterates it by more than 10 times. Naturally, that raises an uncomfortable question. Is this sustainable production, or a carefully staged illusion designed to impress investors and dominate headlines? To understand what's really happening, you have to look at what Tesla is doing differently, not just incrementally, but fundamentally. At its Texas facility, the traditional image of car manufacturing has been almost completely rewritten. Instead of long lines of workers bolting, welding, and inspecting thousands of individual components, the factory floor is dominated by massive machines and synchronized robotic systems. Human involvement is minimal in the most critical stages. Robots don't take lunch breaks. They don't switch shifts. They don't slow down at 3 in the morning. The factory runs continuously, 24 hours a day, with a rhythm that looks more like a semiconductor fab than a classic auto plant. This extreme automation is what makes the 4.5-second figure even remotely plausible. But it also introduces a new kind of risk. Traditional assembly lines are modular by design. If a welding robot fails, production can often reroute, slow down, or temporarily bypass the issue while technicians fix the problem. Tesla's approach is far more centralized. When everything depends on a handful of gigantic machines operating flawlessly, the margin for error shrinks dramatically. Supporters call it the future of manufacturing. Critics call it fragile and dangerously over-optimized. Truth likely sits somewhere in between. At the heart of this transformation is Tesla's use of massive casting machines known as Gigapresses. In a conventional car factory, the rear section of a vehicle might be made from around 70 separate metal components. Each piece is stamped, positioned, welded, and inspected. Hundreds of welds are required, and each weld is a potential point of failure. It's a process that's not only slow, but expensive and labor-intensive. Tesla looked at this complexity and asked a deceptively simple question: why not make it all in one piece? The answer came in the form of aluminum casting machines weighing thousands of tons. These presses inject molten aluminum into enormous molds, forming entire structural sections of a vehicle in a matter of seconds. For the Model 2, Tesla has reportedly pushed this concept even further, using next-generation presses capable of producing multiple complete chassis sections in a single cycle. In the time it takes a traditional factory to weld together a handful of parts, Tesla can produce several fully formed frames, each one ready to move directly to the next stage of assembly. The cost implications of this are enormous. By reducing part counts, Tesla eliminates hundreds of welds, removes the need for hundreds of robots, and slashes both material and labor costs. Estimates suggest manufacturing costs for the chassis alone drop by around 40%. Fewer parts also mean fewer things that can go wrong, at least in theory. There are fewer tolerances stacking on top of each other, fewer joints to inspect, fewer opportunities for defects to creep in unnoticed. But this is where the debate gets heated. Casting an entire structural section as a single piece is an all-or-nothing proposition. If something goes wrong in a traditional system, you scrap a small part or rework a section. If something goes wrong in a giant casting, you scrap the whole thing. And if a gigapress goes down due to mechanical failure, the entire line can grind to a halt. These machines have never been deployed at this scale before. Tesla is effectively betting that the reliability gains from simplicity outweigh the risks of extreme centralization. It's a bold bet, and one that legacy automakers have been reluctant to make. The manufacturing speed and cost reductions feed directly into the Model 2's headline price. Elon Musk has suggested production costs around $20,000, with retail pricing somewhere between $20,000 and $30,000 depending on configuration. That number alone has sparked intense debate. Entry-level electric vehicles from Chinese manufacturers like BYD already struggle to hit profitability at prices closer to $25,000 or $30,000. Their margins are thin, and they benefit from lower labor costs and aggressive government support. Tesla, historically associated with premium pricing, suddenly claiming it can undercut everyone, has left competitors scrambling for explanations. The first explanation is manufacturing efficiency. The Gigapress approach doesn't just save time, it saves money at every step. The second is ruthless simplification.
Ow!
The Model 2 is not designed to be a luxury car. There's no leather, no panoramic glass roof, no high-end sound system, and no long list of comfort features that quietly add thousands to the bill of materials. This is transportation-first design. The focus is on safety, efficiency, and basic functionality, not indulgence. The third factor, and perhaps the most important, is battery technology. Batteries are the single most expensive component in an electric vehicle. The Model 2 reportedly uses a pack slightly over 50 kilowatts, smaller and significantly cheaper than those found in the Model 3 or Model Y advances in chemistry. Manufacturing scale and pack design allow Tesla to extract more usable range from fewer kilowatts than most competitors. That efficiency is what makes the price math work on paper. However, there's a detail Tesla doesn't emphasize in its boldest claims. The $20,000 figure, almost certainly, refers to a base configuration that few buyers will actually choose. Expect limited range, a very basic interior, and a single-motor rear-wheel drive setup. For many consumers, that will be enough. For others, it will feel like a compromise at all-wheel drive, a larger battery, or even a handful of comfort features. And the price likely climbs closer to $28,000 or even $32,000. That's still competitive, but it's a far cry from the attention-grabbing headline number. This raises questions about transparency. Is Tesla being upfront, or is it leaning heavily on a best-case scenario to dominate the conversation? From a marketing perspective, the strategy is undeniably effective. The idea of a $20,000 Tesla reframes the entire EV market, puts pressure on competitors, reshapes consumer expectations, and forces difficult conversations in boardrooms around the world. Then there's the issue of range. Tesla has hinted that the Model 2 could achieve close to 300 miles under ideal conditions, despite its smaller battery. On the surface, that sounds optimistic. But when you consider Tesla's relentless focus on efficiency, from aerodynamics to drivetrain design to software optimization, it becomes more plausible. A lighter vehicle, built with fewer parts and optimized for urban and suburban driving, doesn't need a massive battery to deliver usable real-world range. Still, skepticism remains. Achieving that kind of range consistently, without compromising longevity or performance, is a tall order. It depends on driving conditions, climate, and how aggressively the vehicle is driven. As with all EVs, real-world results will matter far more than lab numbers. Zooming out, the Model 2 isn't just a new car, it's a statement about where Tesla believes the auto industry is headed. Ultra-fast, highly automated factories, radical simplification of design, aggressive cost-cutting enabled by scale and vertical integration. If it works, it could force a painful reckoning for traditional manufacturers that are still tied to decades-old processes and sprawling supply chains. If it fails, it will be a cautionary tale about the dangers of moving too fast and betting too heavily on unproven systems. For now, what's undeniable is that Tesla has shifted the conversation. A car every 4.5 seconds isn't just a statistic, it's a provocation. It challenges assumptions about speed, quality, and cost that have defined the auto industry for generations. Whether this approach proves to be genius or recklessness won't be decided by press releases or investor presentations. It will be decided on the road over years of real-world use. As millions of drivers find out whether a car built this fast can truly stand the test of time.